Hello everyone, my name is Partho Das, Assistant Professor, Department of Electrical Engineering, JS College of Engineering, West Bengal, India. Welcome to my class. So, in this particular presentation, we are going to do what are the synchronizing methods we have in case of synchronous generator. That means we know that we know in the previous classes we have discussed about the what is parallel operation, what are the importance of parallel operation, what are the condition for parallel operation. So when we have discussed about those things, there we have seen that the voltage profile should be matched of the bus bar to the alternate that we have to connect to the bus bar. The frequency should be synchronized, so phase sequence should be synchronized. So those things, if it is synchronized, then only we can connect incoming alternator to the existing system. Now we can think of that okay, so but there is a bus bar is there and there is the alternator is there. Now this alternator is at switch off condition, it is not running, it is at standstill condition. Now connect that system to the bus bar, and then after that switch on that alternator and make it as we need. But we cannot do that. If we do that, so there will be a short circuit, because it has a very low impedance path, so a huge current will flow towards the alternator and the alternator may burn. So we cannot do that. So what we have to do, we have to, at the running condition, we have to connect the incoming alternator to the bus bar system. So as it is at the running condition, so we have to think of that what are the methods we have, so that what are the condition we know that when we have to paralleling the all the alternators, that conditions must be satisfied, otherwise we cannot do that. Okay, so let us see what is written over here. A stationary generator must not be connected to live bus bars because the induced EMF is zero at standstill, resulting in a short circuit. Yes, definitely. So a stationary, that means which alternator which is not running, cannot be connected to the live bus bar. Live bar means the bus bar through which the power is flowing already, so you cannot connect. So then there will be a short circuit, there will be a damage. The synchronization procedure and the equipment for checking is are the same whether one alternator is connected in parallel with another alternator, or an alternator to be connected to the infinite bus. Okay, so maybe there is a system, there is a alternator and there is a load. It is a single system, and now the load is increasing, so this single alternator cannot satisfy the load demand, so another alternator we have to connect to the system. So if we want to do that, there also we need to synchronize. That means that the existing system, the existing alternator with the connected with the load, with that we have to uh, synchronize the alternate that we have to connect it. So here two terms we should know, that is, one is known as the running alternator and second one is the incoming alternator. Running alternator means the alternator which is already connected to the load system and which is already live, but the incoming alternator means that we have to connect. Till now it is not connected to the running system, we have to connect to the running system. That alternator is known as the incoming alternator. Okay, now what are the contents for today's presentation? Synchronizing by synchronizing lamp, advantages of dark lamp method, disadvantages of dark lamp method, 3 bright lamp method, 1 bright 2 dark lamp method, and there is a synchroscope. Okay, so the synchronization by synchronizing lamp. So the set of 3 synchronizing lamps can be used to check the condition for paralleling or synchronization of the incoming machine with the other machine. A dark lamp method along with a voltmeter used for synchronizing in shown below. That method is used for low power machine. Now it is very easy topic, so just carefully view the diagram. I am going to explain you the diagram, then you will very easily understand what is happening over there. So let us see what is there. So first of all, follow my pointer. So these A1, B1, C1 are the three bus bars. Okay, and say in this left hand side we have the n numbers of alternators already connected to the system. Now, and in the right hand side, see this arrow is symbolizing that they are connected to some sort of load over there. Now what is our purpose? We want to connect this incoming alternator, this alternate machine, to the this is existing system. Or carefully follow my pointer. This incoming alternator, this is the incoming alternator. A star connection is given over there for your simplicity understanding. So this incoming alternator we have to connect with this running bus bar system. So to do that, what we have to do, so there is a this section, as you can see. So terminals are taken out from each phase, A1, B1 and C1. At the same time, here from this A2, B2 and C2, from their three terminals taken out. Okay, and in between that there is a switch. This is known as the synchronizing switch. Now the point is, when we can connect those switch, we can switch on that switch. Okay, so that depends when the voltage, when the phase sequence, when the frequency all are matched. At that time only we can connect that thing. So how to check that? To check that, here in this particular method we use three lamps. Okay, so these are the three lamps. Say L1, follow my pointer, L, these are the three lamps. See, let us see how they are connected. So see, what is this? This is the A1 phase. With A1 phase, this A2 phase is connected through a lamp. This AB1 is connected to a lamp, and that is connected to the B2. So B1 and B2 is connected in between the lamp, and so obviously C1 is connected with C2 through a lamp. So A phase is connected with A phase, A1 phase is connected with A2 phase through a lamp, B1 phase is connected to B2 phase through a lamp, C1 phase is connected to the C2 phase through a lamp. Okay, and in between any phase we have connected a voltmeter to check the voltage profile. Okay, so this is the connection all about. That means uh, now from the glow of this lamp we can understand they are in the same phase sequence and same frequency or not, and this voltage voltmeter will show us the voltage level. So let us see what is there. The prime mover of the incoming machine is started and brought near to the before it is not connected, it is not it is like the picture as it is, that system is running there, it is not connected, so that the lamps are not glowing. So now just moving the prime mover, of the alternator, what we can do, we can run the alternator or the synchronous generator and excite the field. Okay, prime rotate moving the prime mover means we are giving a mechanical input to the system. Okay, so the prime mover of the incoming machine is started. Okay, that means mechanical energy we are giving input to the system and brought near to the its rated speed. What when and by rotation we can make its rated speed. Okay, a field current of the incoming machine is adjusted in such a way that it becomes equal. So that now we can change, we have to give the excitation to the system. We are rotating the field. We know that in alternator we have a rotating field, so we are rotating the field at a rated speed. Now at that time we are giving a DC supply to the field winding, and it is generating some flux, and we will set the flux such a way so that whatever flux is generated, due to that there is a flux cutting, and due to that flux cutting whatever voltage is generated, that alternator voltage must be matched with the bus bar voltage to which that system have to be connected. Okay, yes, that thing is written. The flicker, now after when we are doing that, that means the rated voltage is set, and that can be seen in the voltmeter. So that voltage is fixed. Now other two components, phase sequence and frequency, that we have to match with that. So the flickers of the three lamps occurs at a rate which is equal to the difference in the frequencies of the incoming machine and the bus. All the lamps will glow and off at the same time if the phases are properly connected. Okay, so that means how to check the frequency? The flickers of the three lamps occurs at a rate which is equal to the difference in the frequencies of the incoming machine and the buses. Okay, all the lamps, so like this we can check the frequency and we can correct the frequency. And now the how to check the phase sequence. So all the lamps will glow and off, that is dim, glow and dim, like this way at the same time if the phases are properly connected. If this condition does not satisfy, then the phase sequence is not correctly connected. That means if the glow and flickering, if the glow and off of the light is not doing properly, then we can say that it is not properly synchronized. So we have to make them synchronized, then we have to connect. Okay, so thus in order to connect the machine in the correct phase sequence to lead to the line of the incoming phase should be interchanged. So suppose it is not happening, that that glowing and dim is not happening properly as per the sequence. So what we have to do, we have to change then the connection. That means we have to think that okay, the phase sequence are not correct. Suppose so we have to what to any two phase we have to make the change. Then after that we have to check that if that two are flickering right way, if that is if it is not doing that, again interchange. Like this way, by changing permutation and combination, we have to check the original phase sequence. Okay, the frequency of the incoming machine is adjusted until the lamp flickers at a slow rate. That means if the glow, that flicker means this one. Okay, if this is very low like this, then it is the frequencies are same. If it is very high, then it is not synchronized. If it is very low like this, then it is synchronized. Okay, so like this we have to find out that how the phase sequence, then the frequency, those things we can mm, so, and when we have to think that what is the rate of flickering, so that we can say that okay, now it is fine. So see, this point is also written over here. The flicker rate should be less than one dark period per second. Okay, after finally adjusting the incoming voltage, the synchronizing switch should be closed in the middle of the dark period. So that means what we can say, so it is glowing, it is glowing, then it is dark, it is glowing, it is dark. So when it is at the dark condition, okay, so at that time we have to check that when it is at the dark condition, at that time we have to synchronize, we have to connect the synchronizing switch, we have to switch on the synchronizing switch. Okay, so that when it is in again in the glow position, it is already connected to the system. Okay, so this is the procedure by which we can synchronize an incoming alternator to the running system. Okay, so advantage of the dark lamp method, the method is very cheaper. Yes, on we can say that only a voltmeter, some wires and three lamps are needed over there. So what are the disadvantages we have for this dark lamp method? The lamp becomes dark at about half its rated voltage. Hence it is possible that the synchronizing switch might be switched off even when there is a phase difference between the machine. The filament of the lamp might burn out. Yes, it may happen that due to some extra current or any short circuit current or any huge current, for the huge current. The flicker of the lamp does not indicate that which lamp has the higher frequency. We cannot say that the incoming or the bus system or the another alternator, or whoever connected with this incoming alternator which has a higher frequency, we cannot determine. Okay, so these are the disadvantages. So now next method is the bright lab method. In this method, it is this is just modification of the that same dark lamp method. So what we are doing over there, let us see. So in this method, the lamps are connected across the phase, such as A1 is connected with B2, B1 is connected with C2 and C1 is connected with A2. So like this way A1 is connected with B2. So like this way interchange connections are there. Okay, if all the three phases get bright and dark together, this means the phase sequence is correct, and if it is not, just make the change and do that. And the correct instant of closing the synchronous switch is the middle of the bright period. So here in this particular method, what we do, in the previous and dark method, what we do, when it is dark, the bulbs are dark, at that time we are synchronizing the switch. In this bright lamp method, when both three lamps are um, lightning and dark in the same sequence, at that time when it is at the brighter position, at that time we are synchronizing this the synchronizing switch. So this is the bright lamp method, nothing else, nothing extra thing, it is just modification of that method. Okay, that is another method, that again there is a change of the method thing, but the diagram is all the connections almost they are same. So now what we say, the two bright one dark lamp method. So what is there, in this method one lamp is connected between corresponding phase, while the two others cross connected between the others two phase, as shown in the figure below. See, so as we can see, follow my pointer. So that is say these are the incoming A1 B1 C1, and sorry, these are the running A1 B1 C1, the bus bar lines, and these are the say incoming A2 B2 and C2. So as per the method is concerned, in any one phase we have to connect a lamp. So in the same phase we are connecting lamp A1, and in between A1 and 2 I have connected a lamp. Now this B1 and that other two connections are interchanged. So B1 through a lamp it is connected to C2, and the C1 through a lamp it is connected to B2. Okay, so in the previous case all phases are shifted, A1 with B2, B1 with C2, C1 with A2. So like this way, but in this case 1 by 2 dark, so that means one phase will be in the same phase and other two will be interchanged. Now if it is happen here, A1 is connected with A2, so B1 is connected to C2 and C1 is connected to B2. The prime mover is the incoming machine is started and brought to the rated speed. The excitation of the incoming machine is adjusted in such a way that the incoming machine induces the voltage EA1, EB2 and EC2, which are equal in the busbar voltage VA1, VB2 and B1 and C1. The diagram, so like this way, see, this is the the voltage between this is the voltage between what, that the this is the uh, busbar voltage VA1, and this is the alternator voltage EA2. In between that there is a lamp. Okay, and it is C, this is between B1 and C2. So this is the busbar voltage, and it is the alternator voltage. Like that way we have this C1 BC1, that is the busbar voltage connected to through a lamp to this one, it is missing over here, that is known as the B sorry EC1, EC1, this is the EC1. So like this way we can connect and we can check the synchronization. Okay, and this is the last method we have for the for checking the synchronization, and we can connect the incoming alternator to the running alternator or the running system. So what is synchroscope? The synchroscope is a device used for determining the phase angle difference between two or more machines at the time of the synchronization. The synchronization is essential for sharing the load on the bus bar of the power system. The following are the essential conditions for the synchronization. Okay, the we know that these are the condition, the magnitude of the incoming voltage becomes equal, the machines are in the phase with each other, the frequency of the machine remains constant. For parallel operation of these three phase machines, it is essential that they are in same phase with each other. The phase sequence of the device is correct at the time of the installation. Now how the synchroscope is works, so that thing we have to know now. The synchroscope compares the incoming voltage of the machine connected the three-phase system. Okay, and the figure, so in the below section there is a figure. The figure of the synchroscope is shown over here. It has a dial places on the circular calibrated scale on the motor. The position of the dial shows the phase difference between the incoming voltage and the infinite machine. So if it is going that there is a knob that the pointer is showing that the phase sequence in that direction, the right hand direction, clockwise direction, there is the first phase sequence, and the left hand side direction or the anti-clockwise direction there is a slow. So from that phase sequence we can say that the phase sequence, it is going leading or lagging load, those things, and the which has a higher frequency, lower frequency, so which frequency you have to change so that we can connect each other. Okay, so this is the method of synchroscope by which we can connect the incoming alternator to the running alternator. So those are the methods that we have discussed by which we can connect the we can do the parallel operation and the synchronization can be done. So this is all for today. Thank you.